Okay, so today's topic we will be looking at vectors. So our learning intention is to gain an understanding and build our knowledge of what vectors are. So we're going to be successful if we can correctly define a vector, a scalar, a unit vector, and aware of the different notation. Okay, so a vector is a quantity that both has magnitude and direction. So length and a size and a direction. So there's different ways of writing vectors. In print, you might see it as a bold letter, but that's really hard to do using handwriting. So we can write it as a letter with a tilde. If it's a direction like AB, we can write AB with an arrow over it, or we can have a vector A with an arrow over it, and something like that. Okay. So let's talk about some of the types of vectors. Our syllabus defines that we need to know what a displacement vector is. So this is when we know its size and its direction, but it can be placed anywhere on the plane. Yeah, so we can have that vector which might have a length of 2 and it's going northeast, but I can move that anywhere. Yeah. So it doesn't matter where we kind of anywhere that if we have a vector and it's not it's placed anywhere, it's called a displacement vector. We can have equal vectors. These are two vectors that have the same size and direction. So for example, here I've got a vector AB. Let's say it's the size of a length of 1.5. It's the same as xy, and they both go in the same direction. So the vector AB is equal to the vector of xy. We can have parallel vectors, so vectors that have the same direction. If they have the same direction, they are like, but if they're in opposite direction, they are unlike, but they are parallel. So AB and CD, because they're both going east, they are like vectors, but EF is unlike, but parallel to AB and CD. Okay. If you can have negative vectors, so it's like a tug of war. If you have a point and you have the same length on each side, they basically cancel each other out. So vectors that are negative vectors are vectors that have the same length, but they go in opposite directions. So AB is going to the east, and negative A, vector negative A, is going to the west. So if vector A is equal to AB, then negative A vector is equal to negative AB, which is equal to B of A. So kind of telling you which way the direction is going. A unit vector is basically a vector with the length or magnitude of 1 unit. Okay. All right. Let's do some examples. We want to draw a vector showing a ball that is rolled 3.6 meters up a ramp at an angle of 40 degrees. So what I'm going to do, now maybe I'll do the vectors in blue. Yeah, that's fine. Okay, it is going up. There's your 40 degrees. And it's 3.6 meters. And that's my vector there. Here I have a ship from Sydney. Travels from Sydney for 297 kilometers on a bearing of 97 degrees. So what I'll do is I'll use my compass bearings. Alright, so I know that 97 degrees is here. There's my first bearing, so 297. I'll call that vector A. Alright. I'm now then turns and sails on a bearing of 70 degrees. So if that's around about 70 degrees here. Maybe too narrow. Yep. Okay. and that's my vector, that's 365. And I'm going to call that vector B. Okay. Now, I can find the distance it's travelled by calculating this vector, which is going to be the sum of vector A plus B. And I can do that using cosine rule. Yeah. So vector A plus B is going to be, so we got 297 squared plus 365 squared minus 2 lots of 297 365 cos, now if that was 97 degrees, 180 minus 97 is 83 plus 70. Okay, and I can work that out to get so let's do it to the nearest meter. 644 kilometers. So I've got a length of 644 kilometers, and what I could do eventually is I can find the direction it's going in. I can find what this angle is there. Yep. And we could do that by using sine rule. So I can do so sine x over 365 equals sine 3 over 644 x is 365 sine 153 over 644. Let's say 15 degrees. So 97 degrees minus 15 degrees, so in a direction of 82 degrees. Yep. Which is that same measurement there because it's parallel. Okay, so we found another vector by adding these two vectors from tip to tail, which we will learn later on, but that's just an example. All right, let's look at this one. A particle has initial displacement of 5 centimeters. It doesn't say to the left or to the right, but let's just assume it's going to go to the right. Okay, so I start I'm going to start 5 units. Let's say that's 5 units. All right, it moves 4 centimeters to the right. All right, and then it travels 11 centimeters to the left. All right. I could ask myself, what is its final displacement? If I think of that, I started 5 units to the right, I then moved 4 units, and then I went back 11 units. So my final displacement is minus 2 units, or 2 units to the left from my starting point. Sorry. No, minus 2 units from the left from the origin. Yeah. I could also ask, what is the total distance it's traveled? Well, that's just the 4 it travels to the right, and the 11 it travels to the left. So it's traveled 15 centimeters in total. Okay, so a vector is something that has both magnitude and direction. If it only has one, it is not a vector. Okay, thank you.